Hi and welcome. This is part one of our final project for EE542 for 2018 under Professor Young. For the project, we have chosen the challenge two, which was solving mislabeling problem for precision FDA. Here we try to apply machine learning algorithms using Spark, AWS, and Python to match samples which are mislabeled and also cluster which are not mislabeled. Before we dive into the code, let's look at what the challenge is all about. The Some of the data is actually captured from NCI. Some of the data which is shared with us is from NCI, and it's all about sample mislabeling correction. There are two kinds of mislabeling. One is sample mislabeling, which is accidental swapping of patient samples, and the second one is data mislabeling, that is accidentally swapping of patient omics data. They both are obstacles in traditional and basic research because it would lead to detecting cancer for a person who might not even have cancer. The objective of this challenge is for us to learn computational algorithms that can accurately detect and correct mislabeled samples on the dataset provided to us. So we have a few datasets provided, the training clinical data. Let's look at the data. So we have around 80 trainings which the first file says it's classified as male or female with MSI high and MSI low. MSI high is a stage of cancer where you could actually save the person, and MSI low is a stage of cancer where you cannot save the person and the person is almost about to leave the world. Let's go back and look at other data. Train Pro is another data set for the training data where we have all those 80 trainings mapped to every proteomic sample provided, and there are about 4,100 labels, and each of these have 80 different characteristics which we have to make the machine learn and try to identify which one has mislabeling or not. Also, we found out that some of the values do have NA, which are missing. And when we dive into the code, we will go over how we can overcome missing data. Let us go over all the files that are provided to us before we dive into code. The first one is the training CLI, which we recently explained that it has 80 training samples with gender and MSI status. The training pro.tsv is proteomics data, which represents each protein and column as training, which is mapping the previous file. And train RNA is the RNA sequence data, which is used for the sub-challenge 1. Now, our test data would be test CLI, test pro, and test RNA. We would only be looking into test RNA because sub-challenge 2 only asks us to solve RNA, asks us to identify RNA samples. That is for the later part of the project.
So now this is the code, and let us go through it once. We need to import some libraries, so we have imported NumPy, Pandas, and Matplotlib. Now we have a target, and we need to load it inside our data frame. So that's what this is doing. It's creating an if, it's putting it inside the data, and then if it creates an output, it's creating an exception. After that, we need to load the data, and we're loading the proteomics data. Now, proteomics data is proteomics is an extracted protein from protein in our DNA. So all that data that was given to us is loaded. From there, we have to check the training data. So data.head I just wanted to check that it was it loaded inside the data frame and did it give me a proper output, which it did. For transposing as a target, which has 80 outputs, and so I'm running this command. Again, checking the data. Now I need to replace the NaN values inside the data, which was given NaN or not applicable values, by taking a mean of each row, and that's what I'm doing here. Then to check the transposed mean, fill the training data, I execute x.head to check if there is any non-applicable data space or not. So there isn't. Now, to check the label data of the proteomics, I run the y.head. All right. So after that, I need to import from sklearn.assemble, import random forest classifier, and in order to do that, in MATLAB, in Python, there is this random forest classifier. So by using this command, you can easily do that. Now, main important is now that we have loaded the data, we into the data frame, everything, we have checked if it's right. Main important is the feature engineering. So the columns are important on basis of training the data on the Y label. So the target is given to us. We need to train our model such that if the data comes in, it's supposed to give a particular Y label or a Y target. So that's my feature engineering. So the features is the X columns, importance, model the feature importances, and indices is equal to NP. So in the NumPy library, there's an argument sort importance, so taking the top 10 features and showing them to you. In here, 4115 is really maximum. Then 3610, which is the 10th most important. Now, displaying which proteomics are top 10 based on importance. So 4115 is of most importance, as we can see here, and this is of less. We're using the reduced features and plotting it, so we kind of get to see which one is of most and which one is of less. So we wanted to see the points too, and to display how many points in the label are unique, this has to be done. Y dot unique and unique, and we found out that 79 are unique. So because 79 were unique, we needed to use a k-means clustering on the training proteomics, having reduced features, and so we did that. K-means is equal to k-means. These are Python codes, and to display we need y underscore k-means, and this is the array. So 79 clusters.
Now we also have a test proteomics file. So first I'm importing the necessary libraries. After that, as I have a TSV file, I will convert the TSV to CSV using this particular piece of code. First I'm reading the TSV file and then converting it to CSV. by using .to_CSV. Then I will load the testpro.csv file in tdata data frame. If it is loaded, it will show that it has been successfully loaded. I'll just run the commands once again. So as it shows, the data frame has been loaded. Now, in order to display, as we can see, there is testing 1 to testing 80, and there would be in total about 4,118 rows right now. As we can see, there are few values which shows NaN. So in order to make sure that the training is correct, I'm going to replace the NaN values by the mean values of each of the rows. This can be done by using x.mean command, and then I'm going to fill every row with that, every NaN value in particular row with that. Now, in order to display the testing proteomics data with the replaced values, here we can see that over here, as we can see, it was NaN, which has been replaced by the mean value, which was 2.69183, and the same applies for all the other NaN values. After that, I'm going to do a transpose. Since there are 80 outputs in the target data which we are given, we can see that over here, as we can see in the target there are 80 values. So we are doing the transpose. After transpose, I will just display the data. As we can see, there are 80 columns and 4,118 rows. Now I'm going to use the columns which were extracted after feature engineering, which was done using random forest classifier above. So as we can see over here, these are the columns which were top 10, which were like most 10 important columns, and I'm going to use that for the testing data in order to have a uniformity. So that is why I have used a COLS over here. I'll just run all the data frames just to make sure it works. Now as we can see, it ran, and now I'll use k-means clustering on the test proteomics data. This can be done by k-means.predict, and to display the clusters in which every data is predicted, this is the command. So till now, what we have done is using the training proteomics data and testing proteomics data. First, we reduced a feature by using random forest classifier by getting the top 10 most important features as shown over here, and then I classified them in different clusters using k-means. And as we can see, this was for the clustering on training data, and this was for clustering on the test proteomics data. We will be doing the same for clinical and RNA data in the further submissions.
Thank you for viewing the video. Let us know if you have any comments. Like, share, and subscribe. See you in the next video.